Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hi, this is Richard Jacobs with Future Tech Podcast. Today I have Balint Seeber, the Director of Vulnerability Research at Bastille.io. How you doing, Balint?
Hi, Richard. I'm very well, thanks.
Good. Where do you hail from, by the way? You have an unusual name.
I say that I'm half Hungarian and 100% Aussie. So Balint is actually a Hungarian name. My mother is Hungarian. And I was born and raised in Australia. And then a few years back in 2012, I made my way out to the States to follow my passion of software-defined radio.
All right. And now Bastille works on security for internet radio. Is that right?
Yeah, that's right. Our tagline is security for the Internet of Things, and particularly the Internet of Radios. It follows on from the trend that we're seeing that more and more devices are actually being radio enabled. So devices that you may not have even considered to have radios have these cheap radio chips installed in them, and one main purpose is just to ease the ability for one to configure and communicate with the devices and save on cost, because you don't need to install all the wiring to talk to these devices.
So what kind of devices have radio chips in them that people would never suspect have them?
Well, often you see interesting trends in both the consumer markets and sort of markets where devices end up being installed into industrial and corporate contexts as well. I think in the consumer market, especially with the advent of smartphones, if you think about the phones themselves, they've got so many radios in there that just work seamlessly. So you've got individual different components there to enable communication with GSM, 2G, 3G, UMTS, 4G, LTE. You've got Bluetooth, you've got Wi-Fi, you've got Bluetooth Low Energy, you've got NFC for short-range transactions. And iPhones, for example, they have Apple Pay, and Samsung do their equivalent thing. And then you've got in the consumer market all of these new devices now that are making their way into homes. You've got Nest cameras and their ceiling-mounted smoke detectors. They're all wirelessly connected. All of the toys that are making their way into children's playrooms, they are often connected via Bluetooth. You can pair particular dolls and little remote control tanks and stuff. That's all through these common protocols. And then a lot of home entertainment systems and other such devices are all have wireless connectivity features. And as we're seeing across a lot of different contexts as well, the notion of having these hubs, these central points of coordination in your home to talk to smart devices. So, for example, you can have a smart wireless-enabled door lock on your house. And there have been well-publicized hacks that we've demonstrated as well, where you can actually unlock someone's Zigbee-enabled door lock because there's an inherent flaw in the protocol. If you look at devices that are making their way into the corporate world and into infrastructure there, everybody often uses wireless Bluetooth keyboards and mice, and that's a vulnerable protocol that we've shown. I guess we can talk about that later, the particular exploits you can do there. But also in terms of automation and control, as I mentioned, it's costly to install the copper to connect all sorts of devices for monitoring and environmental control. So, for example, in a data center, you might have temperature monitors and other security systems there. And we've seen this in quite a few data centers that we've visited already. You have backup systems for power and for air conditioning. And many times these are installed where the personnel in charge aren't fully aware that they have add-ons that are essentially enable wireless communication to these devices. And if you don't have the visibility into seeing what radios you've got in your environment, then you don't know what's there. And as it turns out, they might just be in their default mode, beaconing out, waiting for somebody to connect. And you know, that's the new frontier that we're really trying to tackle.
When you say a radio, you don't mean just a traditional radio. You mean a device that's beaconing out and calling out to other devices. It sounds like a more general definition. Is that right, or am I wrong?
Yeah. So when I mean radio, essentially in all these devices, technology has progressed to the point where you can miniaturize all of this stuff into a small chip on a board. And the process means that you can do it in bulk, and therefore these parts are very, very cheap to manufacture and then include in one's product. And once you have the ability to do wireless, you can claim all sorts of interesting value adds in your marketing material. The issue is that although it might be easy to add one of these chips, often the security aspect is overlooked. So people are rushing to get their product to market to beat the competition. And we've seen this time and time again, both in the wired world. If you turn the clock back even decades, you can just look at history and see all the sorts of vulnerabilities discovered in implementations of wired protocols and the IP stack and so on. But that same sort of scrutiny still is not applied in the wireless domain. So when we talk about radios, we're talking about all the stuff that gets miniaturized in these products: the antenna, the chip that does the actual physical layer communication, and then on top of that, the embedded firmware that does the control of the radio and decides how to format the packets that are being sent out and handle the data that's coming in. And in our vulnerability research, that's where we look to find these bugs that we find everywhere that allow a potential attacker to take over, communicate with one of these radios and take over the system that's attached to it. And the curious thing about it is that you no longer need to be plugged into a physical network anymore. You can, sit across the road, sit in the room next door, and potentially execute these sorts of attacks.
So what are some of the different ways? You talked about Bluetooth, near-field communication. I know there's a whole bunch more. Which ones are more vulnerable than others? Are they all equally vulnerable? And what's the consequences of someone listening in or sending data or trying to attack various devices? Some of them seem like, no big deal. What are you going to do with it? But some, I'm sure, are more vulnerable.
Yeah, and it's interesting because you wouldn't often consider that something as innocuous as your dongle, USB dongle that you use to communicate with a wireless mouse, might lead to pretty severe compromises. So if I can illustrate that with one example that we worked on specifically, my colleague Mark Mullen, a member of our research team here, actually began looking at taking over people's mice at a security conference, just for fun. So if somebody was showing a presentation, for example, and they were using their mouse to step through the deck or move the cursor around, that was a protocol that he found just by looking at the radio spectrum with some tools, and then was able to reverse engineer and then actually take control of the mouse and confuse the speaker with humorous consequences. But after looking into that further, he discovered that you could actually go in a lot deeper. So one example where you might have a non-Bluetooth wireless mouse just plugged into your computer with a USB wireless dongle is that you can, as an attacker, pair without the knowledge of the victim. You can pair to that dongle, and then you can present yourself as a keyboard to the computer. and then you would essentially be typing as if you were on the computer itself. So the attack scenario is that somebody scopes out a target or targets an entire building, essentially wirelessly connects to everybody's computer through this dongle, has a keyboard, a virtual keyboard attached to everyone's computer. And then if the computer's unlocked and they've left it there or they're looking at something, you can very, very quickly inject keystrokes and type a command that might download some malware and install a backdoor on the computer, and then enable you to exfiltrate data through traditional mechanisms.
That's amazing. So through, you don't have to go through the network to hack into a computer in, let's say, a big company. You can get in through the wireless mouse.
That's right, yeah. And it's not only about injecting keystrokes. A lot of wireless keyboards these days don't actually implement encryption, or they do it poorly, which means that you're able to passively eavesdrop the keystrokes that are actually being transmitted from someone's legitimate keyboard to their computer. So passwords, other sensitive information, you can actually sniff. So it's important for everyone, but particularly in the enterprise where people are very security conscious, to have visibility into those sorts of issues. And
so you can implement a keystroke logger.
You could very easily do that, yes. There's another. So that one actually is called Key Sniffer. We try to come up with some creative names for the various vulnerabilities, but that one's called Key Sniffer. That initial one where you were injecting keystrokes is Mousejack. And there was another one. Where.
So how crazy could this get? Let's say there's a corporation, and you hack someone's Fitbit, and they wear it into work. I don't know if this is possible, but could then the Fitbit be used to, sniff for wireless mice and then get into the computers of the network that way? Or through someone's smartphone that's been hacked?
Yeah, I think it's more likely through the smartphone. And the thing about all these radios are that generally, because they're manufactured in bulk and designed to be cheap, they generally just communicate one protocol. So the Fitbit, for example, it can do Bluetooth Low Energy and fall back to Bluetooth, but that's all it does. So that limits its ability to communicate with other devices. But if you have another device, like a phone that has all those different radios in it, it can talk Wi-Fi, it can talk Bluetooth. And so there are further possibilities there. But the scary thing is where you have the ability to jump from one particular protocol onto the network. So in the Mousejack instance, you're exploiting the fact that these particular radios that have these vulnerabilities are connected directly into a computer that is on someone's corporate network. And then, these sorts of dongles are one particular attack vector. You've got other ones where you might have these, actually we see this quite often in modern buildings. The environmental controls are all Zigbee enabled. So Zigbee sits on top of a protocol called 18.15.4, and that's a sort of generic specification to talk in a different sort of PHY and MAC layer. And then on top of that, people can build their own sort of protocols and systems. And that's deployed in all sorts of different systems and technologies. But it's usually used for short-range communication. We see it a lot in sort of building controls. And that's an area that we're looking into. But again, it completely remains to be seen how secure these things are. So, on the walls, you might have these Zigbee thermostats that communicate back to a central node. That's presumably connected into some network, and potentially another avenue for compromise.
What are some high-profile or maybe just internal stories of attack vectors that made you say, "Holy cow! We got to look at this"?
Well, there was that one published very recently in the last few days that caught our eye, where a researcher demonstrated the ability to take over smart TVs by broadcasting a rogue TV station and embedding within that a special packet containing some metadata that would cause the smart TV to open a address on the internet, because now, of course, everybody's smart TV is connected to the internet. And the TV would then just blindly go ahead and download this payload from the researcher's site. And inside that, you could embed your own malware, which is, I think, what he demonstrated. And so effectively, then you have taken control of the smart TV, which, again, is an example where they've rushed these amazing products to the market. We're connecting everything to networks and the internet, and you're able to get in via this other vector that you wouldn't have imagined. And you can turn someone's TV into a node in a botnet, for example, or you can use it to have a backdoor, and then you can log into their network and sniff around and look at other information there. So that's a very recent example. Yeah.
So it took a long time getting to this, but what's the goal of your company? How does it help either identify or stop these attack vectors? What do you guys do?
Well, we look at the radio spectrum, essentially. We deploy sensors in an area. So, for example, in a data center, on an office floor, or in particular areas of concern like boardrooms and C-suites. We've been looking at the financial services sector at this point, and those radios are able to essentially look at very different frequencies on the radio spectrum and analyze all of the data that's actually flowing over those frequencies. So the radios in these sensors receive all that. We have some very sophisticated firmware running on those sensors that understand many different protocols. And all that information is then sent up into our cloud infrastructure, where we run it through some very sophisticated analytics and localization. And then at the front end of the product is a UI where you can log in through a web browser, see all of the devices in your airspace, and see where they actually are on a map. So if you want to, for example, have instant visibility into all the devices and the different protocols that you have, you can just pop the web browser open and then get a list and see when they're active and when they're not. And that gives you that instant visibility. There's also the notion of personas. So if you consider, say, a device that has multiple radios in it, like a laptop that might have Wi-Fi and Bluetooth, the system can actually recognize that those two distinct radios belong in the same device. And so you can actually pair them and then track them together. You can also consider the historical data there. So if you're doing forensics, there's been some sort of incident, then with the ability to localize transmitters, you can see how a transmitter actually moves through a space. So if you have a transmitter that is attached to, say, an infrastructure device that doesn't move, and then suddenly it disappears or it moves, then something might be awry. And otherwise, if you can track assets in that manner, and if you have people that are entering spaces where they would otherwise be prohibited from entering, so if you have physical security concerns, right, then our system is able to detect whether, say, somebody's phone enters an area, or maybe on a trading floor where all devices are banned, such as a completely cell phone-free zone. If you actually detect somebody's cell phone transmitting information, if a certain area of the radio spectrum lights up, which is essentially their phone talking to the nearby tower, then you can alert on that as well. So we've got a system of analytics that processes all this, and then if we trigger any threat checks, then we offer an alert to the customer that says, oh, hey, this particular device is either shouldn't be on or shouldn't be in this area. That's all, more about device visibility, but we also look at malicious devices too. So, for example, if you might have a rogue wireless access point or a rogue cell phone tower, which are very, very easy to stand up, the actual cost of the hardware is quite small with the advent of modern software-defined radios and open source efforts. We can also then detect that kind of malicious behavior. So if somebody starts a rogue cell phone tower and tries to get people's mobile phones to associate with it, that might enable man-in-the-middle attacks or revealing other sensitive information. Our sensors are constantly surveying the environment, see if any new such transmitters pop up, and then analyzes various aspects of that transmitter to say, this is probably legitimate, or this is configured in such a way where you should be concerned and you ought to send folks to investigate what's going on.
Can you identify? It sounds like you could identify particular devices based on, I guess, their signatures. Can you block, let's say, one person's cell phone from accessing the networks in a particular area, or can you selectively allow certain devices and not others?
So we're just passive at the moment, which means that our sensors are purely receiver only. When you get into the area of active offense, essentially, there you talk about needing to transmit, and that can be quite a can of worms because in unlicensed bands, you might be able to transmit particular things. The one instance of this is existing Wi-Fi access points in certain configurations that we've seen in corporations actually de-authenticate little hotspots. So if somebody was to bring in their own hotspot or enable Wi-Fi tethering on their telephone, then those access points will force you off your hotspot or your telephone when they detect a new network popping up. Beyond that, it's very much unknown. And in the instance of cell phones, you don't want to be transmitting any sort of noise or the equivalent of de-authentication on the cell phone frequencies, because that's actually licensed spectrum that belongs to the telcos. And as a customer of the telcos, you're allowed to transmit with a licensed device such as your telephone. But if you interfere with that, then you basically interfere with the ability for people to call the emergency services and so on. So that can be fraught with problems. So we're purely applying our smarts on the receive side at the moment.
Yeah, it's really fascinating. So what kind of environments have you deployed this in, and any surprises? What have you found? Maybe either in a corporate environment or, I don't know, at live events or other, where do you use this stuff and what have you seen?
Yeah, we deployed to some customers in some very interesting and different environments. We've deployed to data centers where we've seen such things as these Zigbee-enabled infrastructure devices, such as the air conditioning system there, where the folks didn't realize that there was a Zigbee-enabled radio in their control system there. We've seen other elements in data centers where they are wirelessly connected to, and they didn't have the best security setup that might have enabled an attacker to do something nefarious with those devices. In other instances, actually going back to the point that I mentioned about people bringing in their own hotspots, data exfiltration is a big problem, is a major concern. So the idea is to have visibility and to be able to see events where anybody tries to exfiltrate potentially sensitive data through their own channels, which would otherwise be caught by the corporate infrastructure. So if you can't use Wi-Fi to tether, because that's rather obvious and there are active countermeasures for that, one alternative is Bluetooth. So you can, for example, pair your laptop with your phone over Bluetooth and get out to the public internet unfiltered using that Bluetooth mechanism. But at the moment, there's no technology to identify these Bluetooth transactions, these Bluetooth conversations. And that's something that we've been looking at and have been quite successful in seeing. So we've actually seen at another data center the evidence of these Bluetooth tethering events where people might be attempting to get on the internet. It's probably nothing nefarious, but nevertheless, when you have issues around compliance and policy regarding that, then customers are very interested to find out what's going on there. Another issue of concern regarding exfiltration is surveillance. So the idea of being able to keep an eye on other malicious transmitters that might end up making their way into a sensitive environment. So for boardrooms and C-suites and the like, people are concerned about bugs, and these can appear in a variety of flavors. They can be analog